I am Kale SL, RBNB College, Srampur. We see here 12th Science Mathematics Part 2, lecture number 14, and topic is Indefinite Integration, and here exercise 3.2b. Now here question number first, we see here question number first, and we have taken here totally 14 problems. Now problem number 15th, question first, evaluate the following, and problem number 15th here, integration of 1 upon under root of 1 upon under root of x square plus 8x minus 20. X square plus 8x minus 20 dx. Now here we have to convert this problem into standard form, that is integration of 1 upon under root of either x square plus a square or x square minus a square. So for that purpose we complete this square. Firstly call this as I. So let I is equal to integration of 1 upon under root of x square plus 8x minus 20 dx. Now here coefficient of x square is 1. So we take here third term, that is third term, we know how to find the third term, that is equal to 1/2 into coefficient of x is here 8 and bracket square. So 2 4s are 8 and 4 into 1, that is 4. 4 square, that is equal to 16. So we have to add here 16. So I is equal to integration of 1 upon under root of this x square plus 8x and this minus 20 here suppose, and then we have to add here plus 16. So this is plus 16 and cancel this plus 16, it is minus 16 dx. And therefore this required integral I becomes I is equal to integration of 1 upon under root of, now see here this x square plus 8x plus 16, it is a complete square. So how write that square? So in bracket square. So square root of x square, that is x. Square root of x is x square is x. Now here middle sign is plus, so take here plus. And then square root of 16, that is 4. So x plus 4 bracket square. And this minus 20 and minus 16, it is minus 26. So we write this minus 26 as root of 26 square. And now here we use the standard formula, integration of 1 upon under root of x square minus a square dx, that is equal to log of here x plus this root as it is, root of x square minus a square plus constant of integration. Now use this formula, and so required integral I is equal to log of. So log of x is this bracket, that is x plus 4, x plus 4 plus root as it is, this root as it is, that is x plus 4 bracket square minus root of 26 square, and then plus constant of integration. And so this final solution of this problem is I is equal to log of this x plus 4 plus this root. Now if we consider this root is nothing but this same root. So this is the root, and we get this. If we solve return, we get this x square plus 8x minus 20. So we write here x square plus 8x minus 20 plus constant of integration. If we solve this, we get this x square plus 8x minus 20 and plus constant of integration. So solution like this, highlight this solution and take the screenshot and write in your notebook. Now here we see problem number 16. Problem number 16. Integration of 1 upon under root of 8 minus 3x plus 2x square. 8 minus 3x plus 2x square. This is given problem. Call this as I. So I is equal to integration of 1 upon under root of 8 minus 3x plus 2x square dx. Now we rearrange the terms. We write firstly this 2x square and then the term of x and then constant here. Here x square is positive, so write firstly. And so this is equal to integration of 1 upon under root of this 2x square, then this minus 3x and this plus 8 dx. And now here make the coefficient of x square as 1. So take here 2 common and therefore we get I is equal to I is equal to integration of 1 upon under root of take here 2 common in the bracket x square minus 3 upon 2 into x plus 4. See here, when we take 2 common we get x square minus here 3 upon 2 into x plus 4 dx. Now take these 2, 1 upon root 2 outside the integral which is constant, and so it is equal to 1 upon root 2 into integration of 1 upon under root of now here x square minus 3 by 2x plus 4 dx. Now we have to complete this square. We have to complete this square, so we add last term, that is third term. Third term here, third term is equal to 1/2 into coefficient of x. Here coefficient of x is minus 3 by 2 and bracket square. So 1 into minus 3, that is minus 3. Minus 3 square, that is plus 9. And divided by 2 to the 4, its square, that is 16. So we have to add here 9 by 16. So this is equal to 1 upon root 2 in integration of 1 upon root of x square, this minus 3 by 2x as it is here, plus 4 as it is, and now add plus 9 by 16, so plus 9 upon 16, cancel this, so minus 9 upon 16 dx, like this. So it is equal to required integral I is equal to 1 upon root 2 integration of 1 upon under root of here x square minus 3 upon 2x plus 9 by 16 is the complete square of, here take the square root of x square, that is x, middle sign here minus, so take here minus, then square root of 9 by 16, it is 3 by 4 bracket square, and now here plus 4 minus 9 by 16, plus 4 minus 9 by 16 means 4 minus 9 by 16, here 4 16s are, that is equal to 64. 64 minus 9 and divided by 16. And so it is equal to 53. 64 minus 9, that is equal to 53. It is 55. 55 divided by 16. So we write here this plus 55 upon this 16 and dx. See here 4 minus 9 upon 16. This 4 minus 9 upon 16, that is 4 16s or 16 4s, that is 64, minus this 9 upon this 16, and 64 minus 9, it is equal to 55 divided by 16 as it is. So we write this 55 upon 16 as 55 in a root and this 16 as 4 and take its square, so that we use the standard formula. So now here, since integration of 1 upon under root of x square plus a square dx, it is equal to log of ax plus root of this root, that is x square plus a square plus constant of integration. And so solution is I is equal to this 1 upon root 2 as it is, 1 upon root 2 into log of x means this bracket, that is x minus 3 by 4 plus this root as it is, that is root of x minus 3 by 4 bracket square plus root of 55 upon 4 bracket square and plus constant of integration. Now we solve this square root nothing but this square root nothing but this, and this is here root of x square minus 3 by 2x plus 4. So we write I is equal to 1 upon root 2 into log of x minus 3 by 4 plus root of, we solve this again, we get this, that is x square minus 3 by 2x plus 4. So x square minus 3 by 2x plus 4 plus constant of integration. This is the final solution. Highlight this solution like this. So take here a screenshot. Now here we see the next problem, problem number 17th. Integration of 1 upon under root of x minus 3 into x plus 2, x minus 3 into x plus 2 dx. Now here we call this as I. So I is equal to integration of 1 upon under root of a given problem as it is, that is x minus 3 into x plus 2 and dx here. Now we take the product of these two. So this is equal to integration of 1 upon under root of x into x, that is x square, then minus 3x and plus 2x, that is minus x. So x square minus x and minus 3 to the 6 dx. This is the product of these two bracket, x into x here, x square, x into plus 2, that is twice x, then minus 3 into x minus 3x, and then minus 3 into 2, that is minus 6. So x square plus 2x minus 3x, that is minus x, and minus 6 dx. In this way we take here product of these two bracket. Again here observe the coefficient of x square is 1. So we complete the square. So we add here last term, that is the third term, to complete the square, and third term is equal to, that is equal to 1/2 into coefficient of x. Coefficient of x is here minus 1. So minus 1 into bracket square. So it is minus 1 upon 2 and its square is 1 by 4. So we add here 1 by 4 here to complete the square, and therefore I is equal to integration of 1 upon under root of here x square and minus x and this minus 6, this minus 6 as it is here, suppose minus 6, and we have to add here 1 by 4 and we have to cancel this. So we take here minus 1 by 4 and here write dx, and so it is equal to integration of 1 upon under root of, now these three terms are the complete square of bracket square. Which bracket? Here take the square root of x square, that is x, middle sign is minus, and square root of 1 by 4, that is 1/2 bracket square, and here minus 6 minus 1 by 4, that is 6 4s it 24 and minus 1. So minus 25 upon 4, it is minus 25 upon 4. See again here 6 4s are 24 and this minus 1. So minus 24 minus 1, that is minus 25 upon 4, and this minus 25 upon 4 we write as 5 upon 2 bracket square, 5 upon 2 bracket square dx. And now here use the standard formula integration of, since here standard formula integration of 1 upon root of x square minus a square dx, it is equal to, that is log of x plus root of same root, that is x square minus a square plus constant of integration. This is the formula, and therefore this required integral I is equal to so required integral I becomes log of x means this bracket, whole bracket, that is x minus 1 half, x minus 1 half plus under root of this root as it is, that is x minus 1 half bracket square and minus 5 by 2 bracket square plus constant of integration. So I is equal to lastly log of this x minus 1 half as it is plus root of, now observe this square root nothing but this, and this square root is nothing but this. So we may write here in root x square minus x minus 6. Either we write this or we also write x minus 3 into x plus 2. So here I write x square minus x minus 6 plus constant of integration. This is the final solution for the problem number 17. Take the screenshot here. Now here we see 18th, 19th and 20th problem. So these three problems depend on different trick. So here next three problems depends upon the type, integral of the type, integral of the type integration of 1 upon a plus b cos square x dx. Integral of the type integration of 1 upon a plus b cos square x dx, or integration of 1 upon a plus b sin square x dx, or here integration of 1 upon a sin square x plus b cos square x and plus c dx. See here we have to solve the problems, next problems on this type, that is integral of the type 1 upon a plus b cos square x dx, or integration of 1 upon a plus b sin square x dx, or integration of 1 upon a sin square x plus b cos square x plus c dx. Now here when problem is of this type, we put here we divide here. First step is step first, divide numerator and denominator. Divide numerator and denominator by cos square x. We divide numerator and denominator by cos square x. In the denominator, divide every term by cos square x. In the numerator, divide 1 divided by cos square x. And then second step is here, replace sec square x is equal to fundamental identity 1 plus tan square x. Replace sec square x is equal to 1 plus tan square x in numerator only. In numerator only we replace x square x as a 1 plus tan square x. In denominator, we replace here sec square x is equal to 1 plus tan square x in denominator only. In denominator. In here denominator only. In numerator sec square x as it is. In denominator, if sec square x is present, then replace it as a 1 plus tan square x, and then put here, third step is put here tan x is equal to t. Put here tan x is equal to t and then solve the problem. So what is the type here? Integral of the type. If such type of problem is asked in the exam, so we have to go these three steps. In the first step, divide numerator and denominator by cos square x. We divide this 1 by cos square x and every term in the denominator by cos square x, and replace sec square x is equal to 1 plus tan square x in denominator only, and then put here tan x is equal to t and then solve the problem. That problem will be converted into standard formula. So now we see here, take the screenshot. Now we see next problem, problem number 18th. Question number first, as it is, evaluate the following. Integration of 1 upon 4 plus 3 cos square x dx. Integration of 1 upon 4 plus 3 cos square x dx. Call this as I. So let I is equal to given problem. I is equal to 1 upon 4 plus 3 cos square x dx. Now here we divide numerator and denominator by cos square x. Divide numerator and denominator by cos square x. And therefore I is equal to integration of 1 upon cos square x. I write here 1 upon cos square x divided by 4 upon cos square x. 4 upon cos square x plus 3 cos square x. 3 cos square x upon cos square x and dx. Now see here in the numerator I is equal to integration of 1 upon cos square x is sec square x divided by here 4 as it is, and 1 upon cos square x is sec square x, and plus 3, and this cos square x and cos square x get cancelled to each other and dx as it is. Now here in the denominator, second step is over here, in the denominator replace this sec square x as a fundamental identity as 1 plus tan square x. 1 plus tan square x is equal to sec square x, we know. So we replace this, and therefore I is equal to integration of sec square x upon 4 and 1 plus tan square x plus 3 dx. Now here multiply by 4 inside the bracket, and so it is equal to integration of sec square x divided by 4 into 1, that is 4, plus 4 into tan square x, 4 tan square x, and plus this 3 dx. Now here we write this is equal to integration of sec square x and divided by this 4 tan square x, and plus this 4 and 3, 7 dx. And now here we use the third step. What is the third step? Put here tan x is equal to t, because the derivative of tan x is present in the numerator. So put here tan x is equal to t. So put tan x is equal to t, and now we differentiate with respect to x. Derivative of tan x is sec square x. So sec square x is equal to right hand side is dt upon dx, carry that dx, and therefore we get sec square x dx is equal to dt. And therefore this required integral I is equal to integration of here 1 upon this 4 and tan x is t, so 4 t square plus this 7, and sec square x dx is replaced by dt. And now here we write this as integration of 1 upon this 4 is complete square, so we write it as a twice t square plus this 7 as root 7 square dt. And now use here standard formula, integration of 1 upon x square plus this a square dx is equal to, this is 1 upon a into tan inverse of x upon a plus constant of integration. This is the formula, and therefore this required integral I becomes I is equal to integration of 1 upon a. So 1 upon this is a square, so a is root 7, so 1 upon root 7 into tan inverse of x. X means this bracket, that is twice t, and divided by a is here root 7. And now see here, in place of t there is a twice t, so we take the derivative of twice t as 2 into derivative of t. Derivative of t is 1, so 2 into 1, so we divide this by 2, means here we multiply by 1 upon 2 and plus constant of integration. So the final solution is I is equal to 1 upon this 2 into root 7 2 root 7 tan inverse of 2. Now put the value of t. What is t here? T is tan x. So 2 tan x upon root 7 plus constant of integration. This is the final solution. Highlight this solution. And in this way we have completed our 18th problem. Now here 19th problem, second last problem in question number first. 19th problem. Integration of 1 upon cos of 2x plus 3 sin x dx. Integration of 1 upon cos of 2x plus 3 sin square x dx. And now here sin square x is present. We have to use our standard form integration of 1 upon a plus b sin square x, or 1 upon a plus b cos square x. Get it? But here cos 2x is present. So we use here formula of cos of 2x. There are 4 formulas for cos of 2x. Which are those? We know here cos of 2x is equal to 2 times cos square x minus 1, 1 minus 2 times sin square x, then cos square x minus sin square x, and then 1 minus tan square x upon 1 plus tan square x. These are the 4 formulas. Now we have to use here appropriate formula. Here since 3 sin square x is present, so we use second formula, 1 minus 2 times sin square x, and therefore firstly write this as I. So I is equal to integration of 1 upon cos of 2x plus 3 sin square x dx. And now here we use cos of 2x as 1 minus 2 times sin square x, and so it is equal to integration of 1 upon 1 minus 2 times sin square x and plus this 3 sin square x dx. Get it? And now here minus 2 sin square x plus 3 sin square x means 3 minus 2. 3 minus 2 is 1. So 1 sin square x. So here this is equal to integration of 1 upon 1 and plus sin square x dx. Now see here in the denominator sin square x is present, so we have to divide numerator and denominator by cos square x. So divide numerator and denominator. Divide numerator and denominator by cos square x. Therefore this I is equal to 1 upon, now we write directly 1 upon cos square x is sec square x. So 1 upon cos square x is sec square x divided by, here also 1 upon cos square x is sec square x, and plus here sin square x upon cos square x. Sin square x upon cos square x is tan square x dx. We divide every term in the numerator and denominator by cos square x. 1 upon cos square x is sec square x. 1 upon cos square x, here also sec square x, plus sin square x upon cos square x, that is tan square x. And now in the denominator we replace sec square x as a 1 plus tan square x. So this is equal to integration of sec square x divided by, replace this sec square x as 1 plus tan square x and this plus tan square x as it is. And so I is equal to this left side I is equal to integration of sec square x divided by 1 plus this tan square x plus tan square x, that is 2 times tan square x. 2 times tan square x dx. Now here put tan x is equal to t. Put here third step our, put here tan x is equal to t, and therefore sec square x dx is equal to dt. And therefore this required integral I becomes, I is equal to integration of 1 upon this 1 plus 2 and tan x is t, so it is t square, and sec square x dx we replace by dt, like this. So this is the required integral. and therefore I is equal to integration of 1 upon, we write this 1 square, and this twice t square we write root 2 into t bracket square and dt. And now here use standard formula, integration of 1 upon a square plus x square dx. Either here a square plus x square or x square plus a square. Formula is here 1 upon a into tan inverse of x upon a plus constant of integration, and therefore this required integral I becomes I is equal to 1 upon a. A is here 1. So tan inverse of x is here this bracket root 2 t, and divided by a is here 1, and since in the place of this t there is a bracket root 2t, so we take the derivative of this root 2t. We have to take the derivative of root of 2t. Root of 2 as it is, derivative of t is 1, so here it is root 2. So divide this by root 2 means here I write 1 upon root 2 plus constant of integration. Now final solution here we resubstitute the value of t, and therefore I is equal to this 1 upon root 2, we write here 1 upon root 2 into tan inverse of root 2, and t is here tan x plus constant of integration. This is the final solution. So in this way we completed here 19th problem. Take here screenshot, and the last problem in question number first, that is 20th problem. So integration of 1 upon integration of 1 upon here not 1 upon given here sin x upon sin of 3x, sin x upon sin x upon sin 3x dx. Now see here problem is like this, integration of sin x upon sin of 3x dx. In the denominator we use the formula of sin of 3x. So I is equal to, firstly write the given problem as it is, that is sin x upon sin of 3x dx, and so it is equal to integration of sin x upon 3 sin x. Formula for sin of 3x is 3 sin x minus 4 times sin cube x minus 4 times sin cube x. This is the formula. Sin of 3x, use the 34 formula. 34 sin of 3x is equal to 34. Here write sin x, here write sin x, and take here minus, and here take third power. And for cos of 3x use 43, that is here 4 and here 3, here cos cube x and plus 3 cos x, like this we remember the formula like this. So sin of 3x is 3 sin x minus 4 times sin cube x dx. Now in the denominator take sin x common, so it is equal to integration of sin x upon, here take sin x common, in the bracket 3 minus 4 and sin square x dx. Now this sin x and sin x get cancelled, so we get I is equal to integration of, in the numerator 1 divided by 3 minus 4 sin square x dx. And now see here it is in our standard form, that is integration of 1 upon a plus b sin square x. Now we divide here numerator and denominator by cos square x. So divide numerator and denominator by cos square x. We divide directly, so I is equal to integration of 1 upon cos square x, that is sec square x, divided by 3 upon cos square x, that is 3 sec square x, minus 4 sin square x upon cos square x. Sin square x upon cos square x, it is tan square x. So minus 4 into tan square x dx. And now here in the denominator, only in the denominator replace sec square x as 1 plus tan square x, and so it is equal to integration of sec square x divided by 3, and put the value of sec square x as 1 plus tan square x minus 4 tan square x dx. Now here we multiply by 3 inside the bracket, and so we get I is equal to required integral I is equal to integration of this sec square x as it is, sec square x divided by 3 into 1, that is 3, plus 3 into tan square x, 3 tan square x minus this 4 tan square x dx. And so I is equal to integration of, in the numerator, sec square x divided by this 3 as it is, and now here 3 tan square x minus 4 tan square x, that is 3 minus 4, 3 minus 4 is minus 1 into tan square x, so minus tan square x dx. Now put here tan x is equal to t. We put here tan x is equal to t, differentiate with respect to x, and therefore we get sec square x dx is equal to dt, and therefore required integral I is equal to 1 upon this 3 minus tan x is t, so t square, and sec square x dx is dt. So we write this 3 as root of 3 square, 3 as root of 3 square, and now use here standard formula, integration of 1 upon a square minus x square, since integration of 1 upon a square minus x square dx, it is equal to 1 upon 2a into log of, here fraction in the denominator, here a square minus x square, so denominator is a minus x, in the numerator a plus x plus constant of integration, and therefore I is equal to, it is equal to 1 upon 2a, so 1 upon 2, and a is here root 3, so root 3 into log of a is here root 3 plus x is here t, divided by root 3 minus t plus constant of integration, and now we resubstitute the value of t as I is equal to 1 upon 2 into root 3 log of root 3 plus t as tan x, so plus tan x divided by root 3 minus tan x plus constant of integration. This is the final solution. Highlight this solution and take the screenshot. Now here in this way we have completed question number first. That means we have completed 20 problems in the question first. Now here we discuss next type, integral of the form. See here. Now here we have to see question number second, and question number second depends upon two different types, and this will be discussed in the next video lecture. Okay, we stop here. Thank you.